In this video, we're going to solve a couple of word problems, and we're going to do these using two variables, which means we're going to need two equations. These questions can also be solved with one variable, so you can do them any way you want. We've already done in class the method using one variable, so we're going to do them with two variables just to see the difference, but you do whatever you feel most comfortable doing. So a chemist has two acid solutions, so let's start by drawing beakers with those solutions. So here's one and here's two. We have 30% acid in this one, and we have 50% acid in this one. The chemist wishes to make 60 liters of a 38% acid solution. So here's what the chemist wants at the end, and this is 38%, and it's 60 liters. So what we need to do then is figure out how much of each of the blue beakers need to be combined to get the 60 liters at the end. So how much of each solution should be used? Well, first we're going to say we have X amount in beaker 1 and Y amount in beaker 2. If we're going to solve for two unknown variables, we need two equations. So the first equation is the amount from beaker 1 plus the amount from beaker 2 has to give us the amount at the end that we're looking for, which is 60. So there's our first equation. The second equation is coming from multiplying the percentage of acid by the amount. So if we multiply 0.3, which is 30% changed to a decimal, times the amount in beaker A, or beaker 1, that tells us how much of it is actually the acid, plus the amount that's actually the acid in 2 gives us the amount that's the acid in the final one. We know that there's 60 overall. Two equations, two variables means now we can find our solution. Any method at all that you're comfortable with for solving this system of equations is fine. I'll use substitution here, as this can be solved for either x or y. Let's say x is equal to 60 minus y. We can take this then and plug it in for x. So we end up with 0.3 multiplied by what we solved x for, which is 60 minus y from above, and then 0 plus 0.5y equals 0.38 times 60 is 22.8. We multiply this part out then, we end up with 18 minus 0.3y, that's multiplying in the 0.3, plus 0.5y is equal to 22.8. Move the 18, add these y's, so we end up with 0.2y equals 22.8 minus 18 when it comes over, which is 4.8. Divide each side by 0.2. We end up with y equals 24 liters. We need also to find x though, and we have the red where we started that says x equals 60 minus y. Well, we know y now, so 60 minus 24, so x is equal to 36 liters. So we need 36 liters of 30% solution, or 30% acid, and 24 liters of 50% acid to get the combination that we want at the end. The second example is dealing with speed, distance, and time. As soon as you realize that the question has speed, distance, and time, you want to remember our relationships, which are velocity, or speed, is distance over time. Distance is velocity multiplied by time, and time is distance over velocity, or speed. For some of you, you remember it using the triangle. If you're not sure what I mean when I draw this, don't worry about it. But if you do, then we have V there, D there, and T there. And that gives us our three relationships, and these will be useful in this problem. So we have Fatima running at 4 meters per second over flat land. So the speed over flat land is equal to 4 meters per second. The speed over rough land is equal to 3 meters per second. On Saturday, she ran 3,000 meters in 13 minutes over flat and rough terrain. So total distance, we'll just say total distance is 3,000, and total time is 13 minutes. Hopefully you notice that we have meters per second, meters per second. Meters is good, minutes is a problem, so we have to change that to seconds right from the beginning here. We have to multiply by 60 over 1, because that's how many seconds are in a minute. It gives us 780 seconds. So let's get our units together first. Now, we don't even have any variables yet, so what are we looking for? We're looking for distance over flat land. So we can say the distance over flat is going to equal x, and the distance over rough is going to equal y. So those are our two variables. Now we need to use the combination of what we know, which is 4, 3, x, and y, add those pieces together the right way to get our totals, which are distance and time. The distance one should be pretty straightforward. If we go x over flat terrain plus y over rough terrain, we know we go 3,000 altogether. So there's one equation. Now the only thing we have left to use then is the time. So we need to figure out the time over the flat. Well, if we look at our equations, time is given by distance over velocity. So the distance over flat is x, divided by the speed over flat, which is 4, plus the distance over rough, divided by the speed over rough. This is time, distance over speed, this is time. Add two times together, we get the total time, which has to be in seconds at 780. So there's our equation. Total distance, total time. We can now solve this equation. I'm going to solve this one using determinants. It's written x with x, y with y. If you want to use substitution and elimination, those work just as well. So we're going to find x by writing the two determinants that give us the x value. The coefficients then are 1 and 1 over 4 and 1 and 1 over 3. We want to find x first, so we're going to replace the 1 and 1 over 4 with 3,000 and 780 and keep the y at 1 and 1 over 3. Now we need to evaluate those two determinants. So remember, we're going to multiply on this diagonal and subtract the product of the other diagonal. So we end up with x equals 3,000 times 1 over 3. Or you can do this on your graphing calculator. If you know how, that's even faster. Minus 1 times 780 divided by, same thing, 1 times 1 over 3 minus 1 times 1 over 4. The numerator then works out to 220. The denominator works out to 1 over 12. 220 divided by 1 over 12 is 2,640. And the units are meters. We've gotten x then, 2,640. We can find y by substituting x in here and subtracting from 3,000 to get y. But let's check our question. Our question says, what distance did she run over flat land? Well, distance over flat is given by x according to what we wrote over here. So we've already answered the question. This question doesn't require us to find y. We just wanted 2640. So we don't even have to go any further than that. The advantage of using determinants here is you can find the one variable you need if there's only one part for the answer. So that's the end of example 2. We'll stop this lesson here. We'll do the next two examples in the next lesson. Make sure you practice these. Word problems take a lot of practice. Use all the examples that you've been given in class. Go through them, make sure you understand, and as always, get help if you're having problems. We'll see you in the next lesson.